Welcome back to Munro Live. So today we're going to take a look at the Cybertruck doors. Now, I'm mostly an interior person, so we are going to look at the door panels themselves, but we're actually going to look at the door structure and the other components that are involved. So in looking at this door, we have the stainless steel inner, stainless steel outer trim. This is what's called the door module. This is inset into the door and it holds all of the wiring, all of the electrical, all of the components that allow the window to go up and down. Now this is a sealed component because you have a wet side of a door and a dry side of a door. So all of the different areas that puncture through the door skin have some sort of sealing integrated into them. Now an interesting dimension is that this door also has a door control module. This is going to control the door switches, the window regulator. Why is this unique? Well, in the past, Tesla has taken almost all of these controls and integrated them into their body controller, allowing for one main component and then the rest is just wiring. This is kind of a departure from that approach, and we're trying to figure out why. We still have an electrical team that is working through all the modules, all of the electrical and the wiring for the vehicle. The theory right now is because this is a 48 volt motor and other 48 volt systems that are integrated into this, this may be unique for that type of a component. This door module is made by Brose. The door motor is made by Brose. That motor, I'm told it's actually an off-the-shelf motor that has been modified to be a 48 volt and work on that system for Tesla exclusively. So let's take a look at something a little farther broken down. Here's our door module. The door module includes these rails and the other components for the window regulator. This is what allows that window to go up and down. Now let's talk about these components. We have a large injection molded piece. It has a seal that is integrated into it. This is what's sealing off this component. We have stampings that support a casting that supports a stamping. All right, so what's happening here? When I install this into the door, these two holes align with those attachments for the glass. Let's look at the glass. When I slide the glass into the door panel, this is what we are bolting onto that window regulator mechanism. This is an extruded piece of aluminum. There's machining in this, and then it is basically glued to the glass itself. All right. There's a lot of components that make up that system. How simple can that system be? Let's take a look at a Ford. Lightweight stamping. This is an injection molding. See that point? When I slide this glass, you see that point? When I slide this glass into the door, that hole in the glass engages with that lock on that piece of plastic. Well, that's very, very easy. It's simple. It's fewer components. It's lightweight. Why didn't Tesla do that? Well, there's a big reason why. That is possible because the Ford door is a frame door. That glass is trapped in its full path and travel. So when I insert that glass and then I try and completely close the window, it's basically riding in a guide that's going to seal off in the right position. But look at the Tesla glass. There is no door frame. Because there is no upper frame for that glass, I have to set the angle and hold that glass very, very firm. This system allows for that, but it's more expensive. Okay, I always look at things from a cost perspective. So what are they saving here? This door stamping for the Tesla, of course we know it's stainless steel. It is very heavy. This door for the F-150, this is a lot lighter than the Tesla door. Okay, even though this is bigger, it is lighter. So if I were to have increased the size of the outer stamping of this door, outer and inner, to allow for a full frame around that glass, that would have increased the weight significantly. It would have increased the size of the stainless steel that I would have to blank that door out of. I'm saving all of those costs, but I'm making up for it with the extra cost in the window regulator and the glass attachment. So let's take a look at the actual stampings and the sheet metal that make up this door. We have two different stainless steel panels. We have the inner stainless steel panel, and then we have the outer stainless steel panel. They are two different grades of stainless steel being brought together. All right, well, what if they wanted to try and lower weight, and instead of having the stainless steel inner panel, what if they just did an aluminum inner panel and just had the stainless steel skin? Well, in order to do that, they wouldn't have been able to weld those two components together. They would have had to have hemmed. This is a hem right here. The outer skin is literally bent over and attached to that inner skin. All right, so we know that the outer stainless steel for the Tesla is a very, very durable, very, very hard material. We will not be able to hem this material over the inner. Also, even if they were able to, that aluminum now has to go through a paint line. So now we'd have to introduce a paint line after our stamping. We save all of that just by keeping like materials, even though we are sacrificing the weight. All right, so if this is not hemmed, how are these two pieces of door assembled? If you look very closely, you'll see that there's actually a fine laser weld line between the outer skin and the inner door panel. This material is put into a chamber. It is a vacuum chamber, and it is laser welded and cooled in that process. It's a more expensive machine, but it allows for a better finished product, giving the conditions that we need stainless steel to stainless steel. All right, so we have two different grades of stainless steel. You'll see that this inner panel is stamped. All of these deep draw areas, it's obviously a stamping. This is a more traditional type of stainless steel. But what about that outer panel? The outer panel is much thicker. It's a heavier grade stainless steel. It does not process the same way. This is not going through a stamping press. This is actually going through a brake press. The lines, which are very, very straight for the most part, are literally brake bent. They are not stamped like this outer steel. All right. This looks very, very unique. We're looking at the backside. This is a compression molded material that has now been overmolded with a polypropylene resin. We saw this before. This is what was done on the sides of the center console for the Tesla Model S. What am I gaining by doing this? Well, the biggest thing that I'm gaining is light weighting. This is a very, very light panel. But what am I trading for in the process? This material comes in a sheet, which means I have a blank sheet that's filling in all these areas. I'm now forming it. I'm trimming the edges. Then I'm injection molding into the back of it. And because this material has kind of an ugly face, I am wrapping it. I'm putting some sort of a covering to hide that material. So those are all my trade-offs. I have all the material that I'm throwing away from this waste of that sheet stock material, and I'm choosing a more expensive covering process, but I'm gaining something that is very, very lightweight. This type of an approach was done on the BMW i3, but the i3 actually decided to turn that material into their A surface. So when you look at some of the different components, you'll notice that it's not nice and smooth. It's not wrapped. It actually has that look. So they're turning that look into a feature, into a design feature. So what would a traditional material look like? Well, this is an injection molded door panel. This is just hard plastic. By being just hard plastic, this is heavier and it is thicker. Why does it need to be thicker? Because of features like this. Whenever I mold something, I have an issue what's called a rib to wall ratio. Whenever I have a tall feature, this feature actually needs to be a certain size at the base in order to be pulled out of the tool due to die draw. If I look here, because I have this compression mold, it does not matter what my draft angle was. It does not matter how thick my feature is. It's not going to read through. Let me give you an example. Okay, so I'm a plastic person and I'm kind of a nerdy plastic person. Let's say this was my injection molded panel and I have some sort of a rib. I have to have that rib open to die draw. So we know that our tool is going to move in that direction. I cannot have a feature like that because that cannot clear from the tool. So I have to be open to die draw so that when that tool moves, this is going to open up. At the top of my rib, I normally never want that to be anything less than 0.6 millimeters. So if I know the rib needs to be 0.6 millimeters, and I know what my die draw angle is, at the base, that tells me how thick my plastic must be. Because what I'm trying to do is avoid sink. I need the base of my rib to be no more than 40% the thickness of my panel. Why? Because this is an injection molded part, an injection molded material. Anytime you're injection molding or casting, this material is going to shrink. The material always shrinks to its mass center. So if I drew a circle here, this panel is going to shrink to the center of that circle. If I drew a circle here, it's slightly larger, it is still going to shrink to its mass center. Because these are still fairly close, the shrink on the surface is not going to be noticeable. But what about this? Let's say I needed a taller feature. I still cannot be any less than 0.6 at the top, which means I have to get larger at the base. Now, I have a much larger circle, which is creating a different mass center. When my material shrinks to that mass center, I'm going to have a shrink mark. Now, we never want that on any decorative part. This is not a decorative part. This is a hidden part that you would never see. But because of the size of the ribs that are on the back, you can see all of the shrink reading right through that piece of plastic. You would not want to see this on the inside of your vehicle. So the compression molded panel that Tesla has used on this door solves that problem. We now have a material that is completely different from the injection molding. So I can actually have a much larger base, a much taller feature, which is not going to read through just because that outer panel is not part of that injection molding. This solves a problem. It solves a big problem, but it creates three more. So what are those three problems? We have more expensive tooling. The tooling to do the compression molding, the trimming, and the injection molding all in one tool is a much more expensive tool. We have a material that is not nice for an A surface, so now we have to have some sort of a covering. So we can't have a low-cost version that is just plastic A surface. Then there's the material itself. This sheet stock material ends up having a lot of waste. Everything that I had to cut out and throw away, I cannot reprocess and reuse that. So that is waste. So I have waste in my process, I have to have some sort of a covering, and I have a more expensive tool. But I have a nicely integrated part that is very, very lightweight, and it solves the design issue because I can have bigger features that now don't have to be welded onto the back. These are just injection molded onto the back. Sorry about my little nerd moment there. I like injection molding and I like all the things that you have to consider. There is no one right answer. There is no one right way of doing things. All of the conditions that we determine to be within our vehicle have to tie in. Because of this, then this. So I would not want to speak completely negatively about any one OEM or another. And I also don't want to give any one OEM over another too much praise. A decision that worked in this situation may not work in others. If Tesla wants to have a vehicle that costs $25,000, well, they might not want to use this type of an approach. But there's something else to consider in the battery. We look at battery performance based on weight of the vehicle. If I can subtract this much weight from the vehicle, I can actually reduce the battery by a certain amount. Well, if I put a cost to that battery and say reducing the battery by X amount saves me $30. Well, if I pay $10 for more expensive door panels, that reduces the weight by that X amount. I have now saved money overall. The problem that you have within a lot of OEMs is all of these are designed by different teams. A different person is doing this, a different person is doing this, and they're all selfish. They all want to do the best for their system, make their system the lowest cost, or design something that works well for their system, but it may affect someone else over here that causes them to be more expensive, causes them to design something that they did not need to design. If you have someone who is overviewing an entire vehicle and really pointing fingers and say, because of this, this, and because of this, this, it helps out a lot. That is actually something that Munro does. When Munro looks at these vehicles, we are not looking at just one component and saying, oh, this is great. I am looking at this component and considering what it means for that component and what it means for that component, and looking at them together and saying, did we really come up with the best system? So whenever we do our reviews, whenever we do our complete teardowns, it's wonderful looking at something very, very specific, but we want to look at the big picture. And lots of times the people within the OEMs, the people that are actually designing their part, they're so busy and they're so worried about getting their design out the door that they don't have the time to consider what are they doing, what are they doing, what are they doing. That is what we do. So kind of a little plug for Munro there, but it is something really important to consider. There's one other part that I forgot. Notice this little cable right here? This is hidden inside of the door panel underneath a little plastic cover. This is a door release. So in an emergency, pull that cable to release your door. That is hidden underneath this little rubber tray inside of the rear door. I hope you found some sort of insight. There are still a lot of things that we're going to be working through. All of the electrical team is still working through what all of these components are, what do they do, what electrical architectural decisions enabled these different things to work together. So stay tuned for any future videos from the Tesla Cybertruck, and I hope you have a good day.